I'm Javier, and I work as a developer advocate at QuestDB. It's an open source fast database. But today, I don't want to speak really about QuestDB. I want to speak about everything else you need when you want to build an end-to-end solution to ingest, process, analyze millions or even more events per second using, of course, all open source tools. And if you want to, after the talk, I'll be at the Hermit tables. But if you want to ask anything, I'm also on social media, Blue Sky, Twitter, LinkedIn, the Slack of QuestDB. So just find me there. You have also my details, Charlie, on the speaker page of the conference. So I'm going to be speaking about millions of events per second. And every time I speak about fast data, I get people telling me, hey, Javier, I don't really need millions of events per second. And that's right. I mean, I know a lot of users. We are an open source project, so we have thousands of users. And I know some of them really process millions of events per second, but it's a minority. Most people are streaming just a few thousands of events per second, maybe. Some people just a few dozens. Some people might be ingesting a few 100,000 events per second. But truth is, not everybody needs millions of events per second. But still, most applications today have some kind of streaming data. And if you think about it, you can have a lot of data in a relatively short amount of time. So if you think about it, in one day, you have several thousand seconds, of course, times 7 days. In 1 week, you have a lot of seconds. If you multiply by the average month, which is 30 days and almost a half, in any given month, you have over 2.5 million seconds. And if you are tracking anything, like on a per second resolution, if you are tracking 500 tickers on stock markets, or if you are tracking data from 500 sensors on a factory floor, which is a really small number, or if you are tracking 500 users playing a game, using an application in real time, sending data once per second, which is not really that fast for some use cases, very quickly, you're going to find that you have well over 1 billion rows. And of course, databases, like any relational database, MySQL, Postgres, whatever, they can work with any type of data, but they are not really designed to deal with data which is too big or too fast. Even if you can use a Postgres for anything, if you try to process data and send several billion rows every few weeks, or in many cases, we see some users ingesting more than 1 billion events every day. You try to do that with a relational database. If you manage to do it, you're going to be fighting all the time against the system because it's not really designed for that. And one thing about working with fast or streaming data is that it is fairly new. Until recently, we didn't have streaming data. Until recently, all the big data was for batch. And actually, most of the tools that today you maybe relation with fast data, there isn't right now a session on ClickHouse on the other track. So ClickHouse was released only 8 years ago, or QuestDB itself, it was released 10 years ago. Already it's quite old, actually, but many of the tools we use today for streaming data, they are below 10-year-old, and most of them are way younger. So we are not that used to how to work with fast data. There is this guy, Matt Turk, that has been publishing every year for the past 12 years, the landscape of big data. And 12 years ago, this was the first time he was publishing the landscape. He was publishing all these tools for working with big data. This was 2012. And if you notice here, in all these tools, there are only a couple for real time. There is something called Storm that was started in Twitter. There was something on real-time databases. One of these projects is not live anymore because it was acquired by Google Cloud. So 12 years ago, there were only a couple of tools for working with real-time streaming data. And why I'm doing this intro? What's so special about streaming data? Well, if you look for a high-level overview, a batch data pipeline and a streaming data pipeline, they have the same components. First, you need to ingest data from somewhere. Then you need to somehow run analytics. And eventually, you're going to present the data in some report, in some dashboard. Maybe you are transforming the data and outputting to another system. But in the end, it's like 3 steps. You ingest the data, you analyze the data, you output the data somehow. That's basically it. And it's the same for batch and for streaming. Of course, we are in 2024, so you also want to have some forecasting, some predictive analytics. So you will need to have probably an extra component, data ingestion, data analytics, presenting data, and also doing some data science. That probably will be connected with the other parts, but that's kind of the thing. And of course, if you are more into production, you are going to need also to monitor the system. So we have, these are the components you have on a typical data pipeline, and I don't care if it's batch or streaming. You're going to have some ingestion, some analytics, probably some machine learning or something similar, data science, whatever you want to call it. You're going to have a real-time dashboard or report that you need to output, and you need to have some kind of monitoring. And by the way, I just saw on the chat, I have a question from Eric asking how we monitor for latency, throughput, error rates, and all those things. And I'm going to be speaking briefly about monitoring later. So I will touch briefly on that, but I'll probably explain a bit more when I get there. I also see here that I have a question from Vishal. How we ensure that events are ingested in real time without data loss or delays during peak traffic. And that's very cool because I'm actually going to address that in a few slides. So this is the landscape I want to talk about, how we do all those things, ingesting, analyzing, machine learning, real-time, dashboards, and monitoring with streaming data. But if I told you that the high-level overview is the same for batch and for streaming, why is it the case that there were not that many tools a few years ago for working with streaming data? Well, because streaming data or fast data has some things that are quite special. First, it can get very big. If you keep adding data and you never delete things, you're going to get billions of rows before, or maybe just hundreds of millions, but still, you're going to have more data that you are used to in a operational database. Also, the data never stops. So if you want to run any calculation, you need to always find somehow to calculate the data. And if later you get results with an update and you already produce a result, what to do? Can you update something that you already produce in real time? Some databases allow to do that, some will not, but that's kind of the idea. The data is going to be bursty. We have a question from Vishal that I was asking specifically about this. How can you make sure you never lose data if you have a sudden burst of data? Well, there are tools for that, and I'm going to be speaking about that. Data can be coming late. Maybe you have a device that was in a factory and and lost connectivity. Maybe the battery was out. Maybe it was just restarting because of an update and the data was coming late. Maybe you're getting data from different parts of the world and some are coming later than others because of latency, but actually the data was generated earlier. So when you put the logical view, you need to take into account those things. So when you have batch, you don't care about those things because in batch, this is my end data. I can do whatever I want with that. But in streaming, those things are kind of interesting. Also on streaming data, the recent data is very valuable in individual data points for anomaly detection and trends and so on. But after a while, the aggregations are more valuable than the individual data. So it's often the case you want to, after data is getting old, you want to downsample, you want to transform in ways that you can save storage, but still run analytics. So all those kind of things are kind of tricky. And of course, you have to do all of this with low latency. And that's why there were not that many tools for data analytics, for fast data in the past. So when you look at fast data or streaming analytics, the ingestion layer is not just ingesting data. You try to have some kind of message broker. I will tell more about that in a second. So you need to have some kind of message broker. You need to have some kind of message listener. Your database needs to be built for analytics, for real-time analytics. And in the end, you need to choose some components because there is no one solution that can do everything. So you need to integrate multiple components, some for ingestion, some for analytics itself, some for dashboarding, some for monitoring. So you need to integrate all of that. And sometimes they are not built to be integrated, so it can be kind of tricky. And it gets to a point in which there are too many moving parts. And I told you, 12 years ago, this was the landscape for big data. This is the landscape for this year. Same guy has been publishing the same landscape for the past 12 years. And as you can see, things are getting out of hand. We have over 2,000 different products these days to work with data that this guy was tracking. And if you look at any of these small boxes, this, for example, is the one for databases and storage. You have about 20 databases that can do real time. You have also some NewSQL or NoSQL databases and streaming databases that can also do real time. You have to think about how you're going to be storing data. If you look at the streaming or at data science or at data formats, these days everybody's speaking about Iceberg or Delta Lake or Apache Arrow. So all those things are part of the landscape. So when you want to design a solution, you need to think which of the components you want to use and how you're going to integrate with each other. So over the past years, I've been working in many projects with real-time data, and I found myself that every time I wanted to start something, I had to decide on those things. I have to go to my old projects and copy and paste. I had to reconfigure many things. And eventually, I decided to create a template, which is the one I'm going to be presenting today. I decided to create a template on GitHub available for everyone that gives you the foundation to have streaming analytics end-to-end using open source tools. If you go to this GitHub and you clone the repository, you will be able, just starting with Docker Compose, just the Docker Compose app, it will start for you a full stack of different projects configured already with each other and with demo data, with sample data streaming in real time that you can use as the foundation for your projects. So you don't have to start deciding which tools do I have to use, how do I integrate this with each other, how do I monitor, all those kind of things. So the template, when you start it, is going to start a lot of different things. It's going to start a Kafka cluster. I will tell you now which all those things are and why I choose them. It's going to start a Kafka cluster. It will start 2 brokers with Kafka. It will start something called the schema registry. It will start some Kafka Connect workers. It will start QuestDB, an analytical database. It will start Telegraph, which is a monitoring agent. It will start Grafana for real-time dashboards. And it will start Jupyter Notebook to be able to run forecasting or interactive data exploration directly from your browser. And it comes with examples to start streaming data. So I'm going to, first, before I move, I'm going to show you what this looks like. So I've been ingesting data since before we started the call today. And this is the project in action. So I'm ingesting data now in a couple of data sets. So when you start the project, you can just start one of the examples I have from the browser. In this case, I'm simulating financial data. End-to-end is going to be sending data and presenting on a dashboard. And you have also, of course, here, all the data you can query directly from the database. So I have 3 or 4 or 5 actually different data sets on this repository. This is the one, I have one with live data from GitHub. I'm going to refresh more frequently. So this is commits from GitHub that people are doing right now. The other is just simulated data in sending. So this is the project I'm going to be talking about. So the first component we have on a streaming analytics project should be ingestion. And for ingestion, there are many different options, but one that everybody has heard about is Apache Kafka. Because when you are ingesting data, a problem you might have is that ingestion, it can be the flow is never constant. You can have data sometimes come in very quickly, sometimes more slowly. Maybe you want to ingest data from some origin of data to multiple destinations. Maybe you have your analytical database and some data lake, or you want to ingest into multiple systems. So Apache Kafka, it's a buffer that sits between the origin of your data and your data storage. It's called a message broker. Basically, you can send anything you want into Kafka. For Kafka, everything is a message, and you can send in any format you want. So you send data into Kafka, and then you can have clients reading data from Kafka and doing whatever they want with that. It sounds like a very basic stuff, but the cool thing about Kafka is that first, it scales as much as you want. You can add as many brokers as you want. You can grow really high. Since Kafka is very simple, it only accepts operation for writing data, querying data without any, you can just get data by time. Give me the latest data or give me data for a particular point in time, but you cannot do any aggregations, you cannot do anything sophisticated with Kafka. It's super fast to ingest and to query because it has like very simple operations. So you can put Kafka in front of any system. If you have if your system is growing, you can add a new broker, a new instance of Kafka, and automatically the cluster, when I say automatically, operations in real life are never that simple, but work with me here. Automatically, you can distribute data across all the different brokers, all the different instances, so you can grow horizontally as much as you want. The cool thing about Kafka is that it's not only very powerful and very fast, but you can also replay the events. So if you configure retention in Kafka, let's say for 1 week, you can start any application and you can say, hey, give me now the data from 2 days ago until now, or from the beginning of time. If you have 1 week, it will be 1 week. So you can add more retention and it will just use more storage. But it's up to you to decide what's the retention for Kafka. So it's a very cool thing because someone was asking, what happens if there is an error? If there is an error, you can just re-ingest data because it's on the buffer. So even if you have applications sending data to Kafka and then downstream you have any kind of error, you can just reply. So it's a very good way, a very convenient way to have high availability, to be able to write to multiple applications and to be able to scale ingestion without interrupting operations. Okay? In Kafka, you store the data instead of tables, you store data in topics. So the second part is you're going to be sending the data, but which format you're going to be using. You can send data to Kafka in any format. But when we are talking about analytics, you are talking about structured or semi-structured data. So you could be sending data on CSV, but CSV is kind of flimsy. You can send data with JSON, nothing wrong with that. Actually, the data from GitHub I'm sending, I'm going to show you for a second my command line. So I'm ingesting data right now into the GitHub topic on Kafka. And this is the live information I'm getting. It's ingesting data every few seconds. So this is the data I'm getting directly into the topic. I'm ingesting data directly on JSON format. So this is the data I'm sending to Kafka right now. If I check instead my other example, the one for trades, you will see the data is very weird. What's happening here is that the data I'm sending is not in JSON. It's in a different format that I can actually read with some tools. But this is the data I'm sending, decoded, but it's not actually JSON. It's a binary format that is called Abro. So there are many popular formats for working with big data, and Abro is a very popular format on the Kafka ecosystem because it is very similar to JSON. It allows to have nested data, multiple levels. It has a rich data type ecosystem. But the cool thing about Abro is that it allows you two things. It allows you to have a schema evolution. You can define new versions of the schema, and you can have applications working with the old and the new versions using default values and so on and so forth. And the data can be serialized and deserialized efficiently from multiple languages. So when working with Kafka, with streaming data, Abro is a very popular choice. There are other, you can also use protobuf, you can also use org. There are many formats you can use, but Abro is one of the very, very popular ingestion formats for Kafka, and is the one I'm going for in my template. But in the template, as you saw, I'm also ingesting with JSON some datasets. The GitHub dataset use JSON. The rest of the datasets use Abro. So you can choose which one you want to work with. I didn't show you this, but if I go for a second here to my code, this is how you send data into Kafka. And it looks very similar with any language. In this case, I'm using Python, but the API is very similar. You have to point to your broker. The broker is just the port and the host of the available brokers in the system. Optionally, you can use a registry. When using Abro, it's a good idea to use a registry. The registry is just the schemas that you're going to be sending into your data. You can configure if you want some parameters, but it's not really necessary. And basically, the way you send data into Kafka using the API, you just create your producer, you point the data to a topic. A topic will be like a table for Kafka, and just send the data. That's about it. So everything else in this notebook is just for generating data, reading from a CSV, and so on and so forth. But eventually, I only have to point to where the broker lives, send the data, and that's it. So the next step, I'm going to be a bit faster. So the next step is reading data from Kafka. Kafka itself stores the data, but it's not doing anything with that. If you want to get data out of Kafka, you need to use the API to query data and then do something with that. And you need to keep Kafka allows you to automatically keep the offset for every client. So every time you connect to Kafka, it will understand what was the last time that you were reading from a topic. So next time you read, by default, it will give you only data that is new since the last time, even if you can reply. So it will do that automatically. But still, if you connect by hand, it's tricky to keep track of if there is some kind of error, you have to reconnect. If you need to scale ingestion, that's kind of tricky. So Kafka Connect is part of the Kafka ecosystem, and it allows you to configure a topic in Kafka for the origin of data and a destination that can be a file system, it can be a database, can be many different systems. So it allows you to configure the source of the data and the destination of the data, and it allows you to do simple transformations, like I don't want to output this particular column, I want to change the data type of something. So you can do simple transforms, and you can just read data from Kafka automatically. If there is like any disconnect down the line, if it cannot reach the destination, it will automatically retry. So it's very reliable to work with reading data from Kafka. And you can configure Kafka Connect as part of your Kafka cluster, so it can be running directly on the same machines where you have the Kafka broker. So you can scale Kafka Connect very, very much. So, in my example, I actually have here the whole configuration for my project. So in my example, I'm configuring Kafka Connect using the REST API, and I'm just saying, I'm going to be pointing, for example, for the topic called GitHub events, and I'm going to be storing the data using the QuestDB sync connector. And in QuestDB, I'm going to be storing on this table, and I'm going to be using this column as the timestamp, for example. So this is how you configure an integration with Kafka Connect. And in this case, what it's doing in real time, is writing data into QuestDB. QuestDB is a time series database. It's very fast. It allows you to stream data. Let me just for a second to show you. I'm going to stop sending data right now, and I'm going to be sending with a script that sends data a bit faster. So let me just show you, because I told you about million events per second. So I'm going to be sending from this other example notebook, I'm going to be sending data directly into QuestDB. So to send data to QuestDB, I can send from Kafka, I can send from different tools, or I can send directly using the QuestDB API. So I'm going to be sending data to the same table using the QuestDB API, and I'm going to be ingesting. Right now in this table, I have only 5 million rows. So I'm going to be ingesting 30 million rows. So I just started, okay? I started sending data. Let me just go here. And as you can see now, every time I click on select, I have a few more million rows. I can do this query on QuestDB. Give me the data, sample in 1 second intervals, and this is the last 20 seconds. This is how much data I'm ingesting every second. So right now I'm ingesting 1.6, 1.4 million events per second every second. Yeah, so I already ingested the 30 million rows that I have in the script. So as you can see, I can ingest data very, very quickly into QuestDB. And you can run queries over billions of events. We have a demo instance of QuestDB available for everyone. Let me, for example, I have a table here on our demo data set. It has 1.6 billion rows. And I can do things like give me the average, for example, the average distance in this data set with 1.6 billion rows. And in just 200 milliseconds, it gives me the average. So, you can, of course, do more sophisticated queries, like, I don't know, getting aggregations of data in 15 minutes intervals or 5 minutes intervals, whatever you need. So it's a database which is very fast, and it's specialized on working with time series data. I'm going to be going fast now because time is starting to be tight. I'm trying to find where I have the window with the presentation. This is the one. So once data is ingested into the database, and you can ingest several million events per second on QuestDB with a single instance, you can ingest over 5 million events per second. If you need more, you can add more instances, but a single one can ingest 5 million events per second while you are running queries. And then I already told you about Grafana. Grafana is the dashboard that allows you to have this type of, let me just for a second go to the GitHub because I stopped this one. So it allows you to have, I think I stopped sending data altogether. So let me just go to, or I can just show you on the dashboard we have in public, we have to send data. So in Grafana, you have this kind of dashboards. And if you look at any of these, it's just a SQL query. So each panel on a dashboard is just a SQL query that you can explore. I'm going back to mine. So this is just a SQL query that I can present as a dashboard, which makes it very convenient to work with that. You've seen during the whole demo, I've been working directly. I'm going to be stopping. I'm going to be finishing soon. I've been working on the demo directly on my browser. So I've been working this kind of interface. If you're not familiar with this is called Jupyter. Jupyter is an interface that runs on your browser. It allows you to execute Python code, also different languages, but mainly Python. And as you see here, I have multiple notebooks. And a Python notebook allows me to do things like, allows me to mix markdown comments with code. And then I can do things like this. I'm just connecting from here using Python to my QuestDB, to my database. And you can very easily analyze data. In this case, I'm using pandas. You can, of course, plot data. Here you can see the distribution of events that people are ingesting into GitHub. You can work with any tools you want. And since it is Python, you can also do forecasting. I can go, for example, to this notebook. And this notebook, I have an example how to do time series forecasting using ready-made models. There is an algorithm called Prophet, which was created by Facebook, which is specialized on time series. So I just train my model on the data we are ingesting, and this is the forecast of the number of events we are getting from GitHub. And in the same notebook, in the same project, I have also another example using a different algorithm, using scikit-learn, linear regression. And again, I just train the model directly from the browser, and this is what the other model thinks is going to be the trend with the data we have right now. So last part, I don't have the time anymore, but last time we'll be monitoring. We have something called Telegraph. Telegraph is a monitoring agent. It can get metrics from anywhere, and just those metrics you can store in a database. In my case, I'm actually storing the metrics also into QuestDB. So you can see here in my Prometheus table, you can see here I have metrics from my instance directly as part of the template. So this is the data I've been capturing from memory and from commits and so on my database. And with this, what I wanted to show you today is that if you need to do any type of real-time analytics and you don't know where to start, you can just go to GitHub, get a template. You are going to get a template to do ingestion, storing the data, analytics, dashboards, examples of notebooks to do forecasting and exploration. You have monitoring directly as part of the template. And the template doesn't have many things like more data formats, data quality, data governance. It has only basic replication with Kafka, but it's a good starting point if you want to start working with analytics and you want to have an end-to-end solution.